Hey everyone, welcome to the channel. My name is Nader. In this video, we're going to go over symbols in JavaScript together. This is quite an advanced topic. We're actually going to go over kind of the basics of symbols, and then we're going to see them come up repeatedly as we work in JavaScript together. The reason I wanted to put this in here is that since we just looked at generators and async generators together in the previous videos, it's really interesting to see how we can actually use that concept in a practical way with our own objects and classes, for example. We also haven't looked at classes yet, which is going to come up in future videos, but just to kind of get our wheels turning in our head as to how this might work, it's definitely important to actually look at symbols. So we're going to look at the basics of that together. Let's get right into it. Okay, so just to kind of review, we looked at primitive types and variables together in one of our first videos in this series. So just a recap on that, there are these 5 primitive data types in JavaScript, right? There's a string, number, boolean, and then null and undefined, which are the kind of the funky ones because technically we only need one. But since we're in JavaScript land, we have both. And we've seen examples of all of these. And I mentioned then that there are these advanced primitive types, big int and symbols. In this video, we're actually going to explore symbols. We're not going to really look at big int too much, but eventually we might see it in practice. But it's really a case-by-case thing, and we'll see it when we need it kind of thing. And it kind of should just make sense as we need to use it. Symbols, however, definitely require their own explanation and are a bit trickier to understand. So that's the purpose of this video. It's a primitive type. It's actually built into the language, and it has its own set of functionality, very similar to how we might have functionality for these types. So what is this concept of symbols at all in the first place? So symbols are guaranteed unique primitive values in JavaScript. Okay, so we can create a symbol, we can be guaranteed that this is going to be a unique value that we can use in place of a lot of primitive types in things, especially like object keys. So that said, that's kind of the second thing here. We can use symbols as keys inside of objects or in other things that are object-like, and we can kind of like hide them from the traditional things like iterations, like loops and things like that, or certain methods. And I'll give you examples of what this might be like, and I'll compare it to other languages where they don't have symbols, or they use kind of proxies for symbols, for example, in Python, and I'll show you a couple examples shortly. But this is a form of what's called weak encapsulation or information hiding if you want to be fancy with your terminology. It's not a perfect hiding of these values, but it just hides them kind of from regular use, which is definitely very useful. I'm not going to go over it in this video too much, but they can also be registered and shared kind of across different files, kind of in a global scope. We haven't looked at scope yet either. Definitely a complex topic that we need to look at things like closures and other concepts. So maybe this will come up in the future as well. As I mentioned, this is kind of a overview of symbols as it kind of relates specifically to our investigation to things like generators and async generators. So all of this yapping, how do we actually use these things? So here we go. We have some constants up here. And we'll write this in code in a second, but I just want to kind of talk through this and have it be a bit bigger for you on the screen with some colors. So here I'm creating 2 symbols. Okay, you can see that on the right-hand side here, we're using the symbol function constructor to actually create a symbol. Okay, unlike map and set and things like that, we don't actually use the new keyword with these. It's just a regular function, and we just call it with a capital S symbol and then brackets. We can optionally give a symbol a name as well, and it just kind of tags that symbol with what's called a description. Okay, so we can have these 2 symbols here, my symbol and name symbol, and if we log out the type of, using the type of operator for these symbols, we'll see that we actually get a symbol. And this is because they're primitive types, similar to how we get things like numbers and booleans for the other primitive types. Okay. What's really interesting though, is that I said that these are guaranteed unique values. So right here is something that's kind of curious. I'm trying to log out if creating a new symbol, a blank symbol like this, is equal to my symbol, which was also created as a blank symbol. Okay. And this is false. Okay, they are not equal to each other. These are actually two totally separate symbols that have their own kind of unique IDs, and they're totally separate from each other. Very similar to that, if we create a symbol, even if it has the same description, right, the same name here, my name, right, and we ask it if it's the same as the one that had the same name up here, name symbol, right, it's also not the same. Okay, we can be guaranteed that if we're creating a symbol, it's unique. And this might seem kind of pedantic, but we'll see shortly kind of what this is all about and why it's very useful. So before I kind of show you the use of these in objects, which is one of their main use cases, let's just play around with symbols just to get a feel for them in VS Code. So I'm going to pull up VS Code, I'll create a new file, I'll call this intro.js. Let's just start typing some code and seeing what we get. So I'll just call const, and I'll just go with my symbol is equal to a symbol. Now I'll show you what happens if we try to accidentally use new here, and I'll run this code really quick. So I'll make sure I'm in the correct folder. Don't have that command, ls, there we go. And I'll run node intro.js. And you can see that symbol is not a constructor, right? So we can't actually use this new keyword. We'll see what this means, especially when we get to classes in JavaScript. So just know that to actually create a symbol, we cannot use a new keyword. So if I do this, now we get no errors. Perfect. And I'll do the same thing. I'll call const, I'll call this named symbol. And this is going to be a symbol. Let's just give it a name like monkey, for example. Okay. So if I console log these out, let's see what we get. So I have my symbol, and then here I'll do named symbol. Let's run this code. And you can see that we kind of get this special kind of looking thing. It's not really a string. Node colors it in green. Other places might color it differently. But we have this empty symbol thing, and then we have a symbol monkey. Okay, so if we look at the type of these things, and I don't have this in the slide, but it's important to actually see this in code, type of my symbol and type of name symbol. Now, just to recap, the type of operator gives us the type of something. So if I do this, console.log type of, and then I say, for example, hello, this will be a string. Okay, so if I run this, you'll see that I got a string for my hello, but then these are the symbol types, which are built-in primitive types to JavaScript. Okay, so here is kind of what I had last on the slide. If I try to create a new symbol and I ask if it's exactly equal to my symbol, we're going to get false. Okay, because even if we create a symbol that's blank, even though this is also blank, they are two separate symbols, very similar to if you think of it how we could have two separate arrays or two separate objects. Just because they're empty doesn't mean that they're the same. They're actually two separate things in memory completely, and they're handled quite differently. So same thing here, if I say console.log, even if I name the symbol the same thing, let's say I call this monkey, I ask if that's equal to our named symbol, this is also going to be false because same rule applies. Just because it has the same name, it's actually a different symbol. All right, now there are ways for us to actually make sure we are using the same symbol name. So for example, if you think about this, if I use console.log and if I say, is it equal to itself, right? Now this is true, right? Because obviously it's equal to itself. However, there are ways to actually register these symbols kind of globally so that we can kind of look them up and grab them and use them in different places if we need to. But we're not going to go over that in this video because it's less used for our purposes, and we're going to mainly use this to do things like iteration and async iteration. Okay, so that's just kind of the intro to how symbols work. Just declaring them, creating a new symbol, and we can create them with a description as well. Just want to show one last thing really quick before we actually switch back to the slides. If I do my symbol and I can grab a description out of it, I can do the same for named symbol. They have a description property, and if I run this, we'll see that description for the empty symbol is undefined, and for the one that we gave a name of monkey or description of monkey, it's actually going to have that name pulled out. So it does save it somewhere inside of that construct of it being a symbol. Okay, now this is all very abstract, right? I haven't really showed you really very much at all. I've showed you that we can create these symbol things, and it's like, okay, great. What are they? Can we do math with them? Can we do other things with them that we couldn't do with numbers and string and things like that? So why are these used, right? What's the purpose of this? We just created it, and now what do we do with it, right? So I want to show you an example. Imagine here that we have an object. Okay, so this is a character, like we're calling this a character, just a regular plain old JavaScript object. This object has 4 keys. Okay, it's got a name, Rick Axley, a class, Axe Wielder, a quote, I'll never let you down, and then we have this underscore admin property, which is going to be the Boolean value of false for its value. Okay, now if we did this, right, if we did for const key of object.keys of this character, object.keys is going to give us back an array of the keys, in this case, name, class, quote, and admin, right? And we would be able to log that out if we want to. We get something like this. This would be all separated on different lines because we're looping in one at a time, but we get name, we get class, quote, and then admin all on separate lines. Okay, so let me just show this to you because this is really the purpose of symbols. So I'll just call this admin.js. I'm just gonna copy this character here just so you don't have to watch me type too much. Let's just say we have a name property, a class, a quote, and then an underscore admin property and underscore. Now I do want to kind of bring up why other languages do this, and I'll show you what the difference is with JavaScript in a second. But if I say for const key of, and then I can use the object.keys method to actually grab the keys out of character, very similar to we can do object.values and object.entries to grab both of them together. So if I say object.keys of character, and we have to do it this way, and we'll see why when we look at classes later. But when we grab all these keys, we'll grab each key one at a time and then we log it out. So just because this is underscore doesn't actually make it like unique. It's just a name. It's just named differently. JavaScript doesn't actually care that this is underscore or whatever fancy naming we use to try to make this special, right? So if I run node admin.js, we'll see that we get all of those keys logged out. Okay, so here is the kind of challenge. In other languages like Python, for example, the underscore properties can be treated differently because they are meant to kind of be hidden or reserved or like contain special functionality for objects and classes and things like that. Now, in JavaScript, we don't have that ability, right? Sometimes we can give names to things and we just kind of assume that that thing exists, and other functions might assume that that exists. So a common one is this one, which is toString, right? And then this would be like a function that returns the string representation, for example, like Rick, right? And if we were to log out this character, this wouldn't work right now because we would need to do this in a different way. But if we were to kind of log this out or ask for the string representation of this character, we could give it whatever we want, and then it would be called in the toString. Okay. Now, a lot of languages use this concept in this way, right? In the underscore way, which is fine if that's the standard. However, it's a little bit ugly looking in my opinion, because it would be nice if there was kind of a very standard way to actually give a name to these properties that's kind of hidden or that has a truly special meaning. It's not just a string, just like everything else. If you recall, these are all just these, right? These are all just strings, including this underscore admin right? These are all just strings. It doesn't actually matter, right? The strings get removed when I save this because of my editor, but they're all just strings. Now, what's interesting is that symbols are not strings, okay? Symbols are their own type in JavaScript. Okay, and we can use them as keys for objects, and they are not treated the same way as strings. Okay, that's really the key here. So we can avoid doing kind of hidden features like this. So imagine for Rick Axley over here, we don't want to really always show admin every time we're looping through the character. We just want the name, class, and quote, right? But we do want to store this information on this character, but we just don't want it to be able to be looped through, for example. There are other ways to do this. However, using symbols is probably one of the better ways. Okay, so let me show you what I mean in a sec. So if we do this is a small change and accomplishes exactly what I'm talking about. Here we have the same character, name Rick Axley, class Axe Wielder, and quote, I'll never let you down. Okay, but here what I'm doing is I'm setting a new property, which is a symbol, and I'm giving it a name of admin, and I'm giving it the value of false. Okay, so same thing as here, but instead of using a string as a property name, I'm using a symbol. Now we have to use these square brackets because I'm creating the symbol in place, and I'll show you how we would do this with a string, for example, just so you can see the context. But the most important thing to take away here is we're creating a symbol as a key for this object. And check this out now. If we actually for of loop over this with object.keys, we do not get symbols. Okay, because symbols are hidden from iterations on things like objects and stuff like that. Okay, the intention of symbols is to hide functionality inside of this object in various ways so that it can still exist and we can still grab it. However, it's not going to show up kind of in normal circumstances. Okay, that doesn't mean that it's not accessible if people know the symbol names, and there's other ways to grab all the symbol names off a property, and I'll show you that, or object, and I can show you that in a second. But just by default, we at least hide some of that behind the scenes. So we don't clutter up the namespace of this character with random strings that are like __ or all caps or anything like that. All right, so let me go back to VS Code and let's do this. We'll call this Symbol.js. I'm going to copy my character over. Oops. Actually, I'm going to copy all of this code over. I'm just going to copy everything from my admin.js, including my for of loop, over to my symbol.js, just so we have a bit more space. And instead of this here, admin property, being the admin property __ as a string, I'm going to give it square brackets. And I'm going to say this is going to be a symbol, and I'm just going to give it a name. We don't have to give it a name, but I'll just give it a name. Okay. Now, check this out. If I run node and symbol.js now with our same for of loop, and the only change here is that now this is a symbol property, we don't get that property printed out. Okay. So now this is hidden from all of our iteration methods going forward. Very, very useful. Okay. Now, what is this square bracket syntax? We haven't really looked at this too much before, but this just allows us to evaluate a statement and use that as a property name. So for example, if I wanted to do something like 4 + 5, I could do that in here. And then this could be age, for example. It would technically be the reverse, but let's just go with that for now. And if I run that, you can see that we get 9 as the actual property name, right? Because this evaluates to 9, and then that gets put as a key for this value. Same thing here. This gets evaluated as a symbol, and it gets put as a key for false. But the difference between these two is that this 9 gets turned into the string 9 as a key, as we saw in the object video, but this gets turned into a symbol, which does not get displayed when we loop over it. So 9 is a key as a string, so is name, so is class and quote, but symbols are not displayed. Perfect. So one thing I want to show as well here is if we did want to see all of the symbols associated with an object, we could do object.get own property symbols. I'm just going to click that so you don't have to watch me type it. Get own property symbols in camel case, and we can pass it a object. In this case, I can pass it character, and then I can console log this whole thing out, right? So if I do console.log and I log out this entire thing, which is saying object.get the property symbols of this object, let's take a look at what we get. You can see that we get the symbol in there, which is our symbol name. Okay. You can imagine if I give this another symbol, I say age, for example, and then I say 10, right? And this is a second symbol here. Now, if I run this, we'll get both of those symbols as an array. One is the symbol name, one is the symbol age. Okay. Hopefully that makes sense. And you can still see that these are not being looped over when we go through our for of loop. The only way to access these is through the getting the own property symbols. Okay, great. Whew, that was a lot. So now kind of the whole point of all this, right? Let's look at some well-known symbols. Now there's quite a few of these symbols all over kind of the way that objects work. However, I just wanted to pull out a couple, specifically these two, but I'll mention the string one as well. So there are these kind of named symbols that are actually kind of globally registered to some degree, or they have like a special meaning, I guess is technically the correct way to say it, where if these symbols are seen inside of an object, then they are treated specially. Very similar to maybe the idea of a toString, which is what this one does. These ones are treated specially. So what does that mean? That means that if we have a property very similar to this, and I'll show you how we do this in a second with one iterator, that's called Symbol.iterator. That is going to allow us to for await of loop using a generator or an async iterator through that object. Same with Symbol.iterator. This is a regular generator or a regular iterator function. Symbol.toStringTag is going to give us the string representation of that object. This mainly works with kind of the new keyword for functions, as well as for classes. So we'll see this later on when we want to kind of show a string version of things like classes and functions later. So we're going to focus right now on this one, and we'll see an example of this one in the exercises. So to create this one, let's see what that actually looks like. And actually, before we actually go through this, I want to show you that there are many more of these, okay? So if you pull up Google, if you go to Symbol.js, okay, hopefully you get the MDN web docs show up, which is the symbol documentation page. And if you click on that, you'll get the symbol documentation page. After you scroll kind of down a little bit, eventually you'll get to the well-known symbols section. And where are they? Did I skip over it? Probably like, oh, you scroll right by it, Nader. What are you doing? What are you doing? Where is it? There we go. Well-known symbols. So we can ignore all of this for now. This is all just a whole bunch of fancy wording. But effectively, what this is telling us is that there's kind of a list of well-known symbols. For example, symbol.hasInstance. And then, as I mentioned, traditionally there's things like toString and value of. So if we scroll down a little bit, we can see some of these. And these are the ones that I listed. Symbol.async_iterator, which allows us to use an async iterator in a for await of loop. We can skip over these for now. Then there's Symbol.iterator, which allows a regular for of loop as a regular iterator. There's a couple of these that are going to do things with regular expressions, which we're actually going to go over through together shortly. And there's a whole bunch of other ones in here. toStringTag will return a string representation of an object. So let's go back to VS Code and let's create a iterator.js file. And what I'll do is I'm just going to copy the same thing just so that you don't watch me type too much. I'm going to copy our Rick Axley character because this is great. And we're going to actually use this to create a iterator symbol. So the way that we do this is we add a new key onto this object, and we do symbol, and then we do dot, and then we can get access to the kind of well-known or previously named ones. So for example, iterator. So we don't call this, we actually just do it just like this, symbol.iterator. We don't call it or anything. And this is a key, so we're going to give it a value. The value needs to be an iterator. And we didn't go too deep into iterator, but we saw that a generator function technically gives us back an iterator, so we can actually use that. If you're not familiar with generator functions, I have a video that kind of goes into those if you need it. So we can do a function star. And for example, in here, I can do things like yielding 1, yielding 2, and then yielding, like, for example, hello, right? Just for fun, let's just yield 3 values out of this generator. Okay, so check this out. Now that we have this special symbol on this object, right? And this is a symbol that we're adding. We couldn't add a string to do this. This is a very, very special reserved kind of thing in JavaScript that is a symbol object. We can actually loop over this using a regular for of loop. So I can say for const, and I can just say value of character. Now keep in mind, even just looking at this, we cannot loop over an object normally using a for of loop because it's not an iterable. Okay, an array is an iterable, so with things like maps and sets, but an object is not in JavaScript. If we define the Symbol.iterator property on it though, we can define our own version of what it means for an object to be iterable. In this case, I'm just saying it's going to return 3 static values and then stop, but you can imagine how we can do very powerful things with this. So if I console.log the value here, let's see what we get. So I'm going to run node iterator.js, and you can see that we actually get those yielded values out of that object when we're for of looping over it, which is pretty amazing, right? This is not normally possible with an object. And we can actually define this on things like classes and our own custom objects and allow them to be iterated on, or even async iterated them on in our own defined custom way, which is extremely, extremely powerful. Okay, so I hope that kind of was useful for you. What we did here is exactly this, right? So keep in mind that we created a custom iterator property using symbols on our object. In this case, I'm using yield delegation, which we covered in the previous video on regular generators, but it effectively does the same thing in this case, where we're actually looping over this object and yielding out these values out of this generator. Okay, so we're yielding 1, then 2, and then this string, for example. Okay. So we'll see many examples of where this actually becomes useful. What we're going to do in the next video is just get some more practice with such examples. And as we learn more topics with JavaScript, we're going to be able to start seeing where these symbols actually exist, how they work behind the scenes to kind of make things and structures like this in JavaScript actually work for us and actually iterate and create iterables and all that kind of stuff. Really, really awesome that this is a feature of the JavaScript language, because previously we had to kind of deal with things like this, which is less ideal and kind of susceptible to a lot of errors. So we'll go over a lot of these things like information hiding and things like that as we get to classes. But I hope that this was valuable and you learned something from this video. If you did, I'd love it if you could like the video and subscribe to the channel. As I mentioned in the next video, we're going to go over a bunch of exercises to get more practice with symbols and kind of see how they work with iterators and async iterators specifically. I'd love to also hear in the comments, have you ever seen this before in an object before? If you've logged it out somewhere or tried to grab properties off an object. Specifically, have you ever kind of been curious as to what symbols are? Or have you even used them yourself to do anything interesting inside either objects or classes? Or if you created your own libraries, for example. I'd love to hear what you've used symbols for in the comments. So that said, I'll see you in the exercise video for symbols. See you later.